Hello guys, this is Trista. So I'm so happy to give this talk around how to upgrade your existing traditional databases, for example, MySQL or PostgreSQL, to become a distributed one so that you can leverage the distributed database system to have the higher performance and make your querying become faster and to give you the out-of-the-box deployment solution. Right, so let's get started. This is about myself. I'm the Trista now. I'm at the Sophia's, working as the co-founder and the CTO. My area it's about the distributed system around the databases, around the automatic databases management platform. So I spend my time in at the technology and also in some open source foundation. For example, Apache Software Foundation. I'm the Apache member and incubator mentor to help to give some of the tips to some of the open source projects in their community. Yeah, so sometimes I will post some articles about the open source, monetization, about the databases and the cloud databases on my Twitter and LinkedIn. If you're interested in such a topic, welcome to give a look there, right? And today we will have the following topics we will talk. The first one, I will give the current scenarios because we have the new technology, we have the new needs, so we need to do some change around our database infrastructure. And second one, let us dive into the distributed database system and to look at what is happening in the distributed database system now. And then I will give them new ideas or solutions, like I said before at the beginning, how to make your favorite PostgreSQL or MySQL or SQL Server or Oracle to become a distributed one, to become a distributed database system. And then if we have time, I will introduce my demo show and to let you learn it or deploy it one by one. Yeah, so first one, when you talk about the new scenarios, because in this new era, we have some new technologies. All of them are good features or good technologies to provide their values for BI. I mean, the business, your commercial, your customer. But for SPCO for big data or databases, actually all of the new scenarios make us have the new definition or about big data's characteristics. That means the big data's 5V, they are the value, veracity, volume, vacancy, and variety. I will give the brief introduction about each of them. The first one about the value. That means we need to use some of the AP, OLT, AP, or use some of the big data architecture or the solutions to help us do some of the statistics, so we can know more about our business or give the product some of the good feedback, right? The second one, it's about veracity. That means we need to guarantee that the data we collected are correct. So if we use this data to create some of the data model to do the BI work, that means that they are the valuable. If we use the wrong data to do the AI, that means we will get the wrong result. We will guide our product or companies to the wrong direction, right? The next one is about volume. That means you know that in the internet that people create the data every day, every minute, every second. So that means we need to manage the tremendous data size. And next one is velocity. That means that our end users or other departments, they really want to get the result or the queries, the results as quick as possible, right? So they want to get the real-time results or do the near real-time process or data stream. The next part is about veracity. That means your databases or your database store or data store need to help you manage the structured and unstructured data. So that's the main innate big data's characteristic. Based on all of the characteristic, we need to solve all of the issues, use our new databases architecture or new databases solution or product. But before we introduce all of them, I just want to give a little bit introduction about the OLTP, OLAP, because we cannot use one single database or product to solve all of the issues, right? Or to meet all of the requirements from our previous slides. So generally speaking, we split the scenarios into two. The first one focuses on the OLAP. That means to process a large amount of the data quickly and to do the analytic. The second one, it's about OLTP. That means, or this kind of databases or productions, they want to handle the large volumes of the transactional data involving multiple users, right? When we speak of the MySQL or PostgreSQL or Oracle, actually they are all belongs to this type of the databases. So today, I just want to pick up the OLTPs area to give my solution and my idea. Yeah, so but if you have some idea about OLAP, maybe later on I can give other talks about around that topic. So now I know people love the MySQL or love the PostgreSQL, or some company will buy some of the Oracle databases, right? But you can see that all of the monolithic databases actually for them it's too hard or too difficult to manage the structured data, especially data STP or BP, all of them kind of like a tremendous data size, right? So people will consider how to use some of the distributed databases or new SQL databases, for example, the CrocodileDB or MongoDB or the Aurora or such kind of the databases solution, right? So, but we need to ask the question, why people want to adopt the new solutions at this point? Because that I introduced before, that the monolithic databases, it's for them, it's very hard, to help us to manage all of the structured databases in BT or PD, right? And plus, that the service at the beginning, they're the single one. They're deployed in a monolithic machine, right? But now you found it split in the service, the microservice or serviceless, right? And people will use the Kubernetes to manage all of the services, right? So you can see that the services, it's become the distributed one, it's splitted, it's sharded, and your server actually on the same way to do all the stuff. At the beginning, maybe you can just use the one server to do all the stuff, but later on you found that if we can use the cloud, the pod or container or the Docker, you found it's easy for us to manage and to skew in or skew out. It's make this system become, or the server, make the infrastructure become the distributed and become the elastic skew in or skew out, right? So that's the power of the distribution. And how about the databases? Actually, big databases currently at this point, people use the same idea. That means the distributed or sharding or the splitting, the architecture to split one single databases into a distributed cluster. To make this cluster can help you manage the tremendous data, enormous data, and can help you to do the elastic skewing and skew out based on your needs, right? So you can choose the pay as you go, this model. Yeah. So at this point, you know that we need to use some of the distributed databases for some necessary needs or cases. But I know most people, maybe at the 5 years ago or 10 years ago, you are so support the PostgreSQL or MySQL. But now you need to consider the upgrading all the stuff. Okay, you can actually just at the beginning choose the distributed databases, but I guess most of are still in the progress of the evolution, right? How to make it become the distributed one. And today, so I want to share another solution to help you to own a distributed system based on your existing PostgreSQL cluster or MySQL cluster, and make this distributed Postgres cluster have the skew in, skew out, elastic skew in, skew out features, or rewrite splitting like the traffic governance features into this cluster. So how to do that? We need to know that when we speak of the distributed databases, actually most of them adopt the computing storage splitting architecture. That means in this distributed system, it's made up of two important parts. The first one is the computing part. That means the computing nodes. The second one, the storage nodes, right? So based on this idea, if we want to make our monolithic PostgreSQL become a distributed one, actually we can regard or view PostgreSQL or MySQL as the storage nodes, different storage nodes. It's PostgreSQL means the one storage node. And then all of the storage nodes, they can do some of the local computing work and help us to persist your data, right? So if we want to create this distributed system, then we need the exact global computing nodes, right? So who can become the distributed nodes? Later on, I will introduce the Apache Sharding Sophia. It can work at the computing nodes. So use Apache Sharding Sophia plus your existing favorite MySQL, PostgreSQL, or Oracle. You can have the distributed one. So what's the Apache Sharding Sophia? All right, before that, I need to give some of the benefits of this solution. The first one, it can leverage your existing database cluster. That means you don't need to overturn the whole of the infrastructure. The second one, you can leverage the ecosystem of the mature PostgreSQL deployment or maintaining the ecosystem of the PostgreSQL or MySQL's maintaining work and deploy work, right? You have a lot of mature tools, or the DBAs can help you deal with all of the stuff. The third one that I will give more like the SQL audit or traffic governance or elastic scaling, all the features into this solution, right? The next one that it can help you consider how to move your databases into cloud. I mean, because we use the storage and computing splitting architecture, that means your PostgreSQL working at the storage nodes and are deployed in on-premise, but you can use Apache Sharding Sophia working at the computing nodes and are deployed on the Kubernetes or on the cloud, right? So that means you can use this solution to solve the headache of database on cloud, such issues. The next one that it will provide you the out-of-the-box deployment. I guess most of the products will give such feature, right? It's not the highlight one. Yeah. So let's move to the next page. What's the Sharding Sophia? Before I introduce the feature of this product or this project, I just want to say that it's the big community, open source community. It's the Apache top-level project. And because it has been open sourced for more than 6 years, so you know that people love it. So there are many contributors, committers, active there, and it released for more than 50s. So you don't worry that it's a brand new project and for you, because people will worry about that oh, if I have some questions that cannot get help from the community, or oh, it's a new one, so people will worry about the quality and his stability, right? So but all of the issues don't exist here because it's a big one, and many people or companies use this project for their production environment, and it provides a friendly document for you to learn more about it. And that's why I want to introduce the feature of this project. Generally speaking, Sharing Sophia provides 2 clients for you to choose. The first one is Sharing Sophia JDBC. It's a lightweight JDBC driver for your Java application. It's a framework. So you can use the native Java interface to use Apache Sharing Sophia JDBC and help you to reach the following functions. The first one, data sharding. That means to shard your data into different database instance, right? Make it become the distributed database one. A second, and about the distributed transaction, and also rewrite splitting. If your databases have many replicas and you want to input the QPS or TPF system, you consider how to leverage all of the replica one, right? For example, to send some of the select queries to the replicas ones, right? So at the beginning, maybe you consider use the load balancer, but now if you use Sharing Sophia, no matter it's a JDBC or proxy, all of them can help you automatically do the load balancer stuff and send the update or delete queries to the primary instance, and send all of the select queries to the replicas ones, and can, for example, use the random strategy or use the round-robin strategy to leverage your replicas into the instance. And also it can help you do the data masking or data encryption. All of them, I think it's so valuable features, because you know that you want the data in the databases are encrypted, right? But how to do that? If you use Sharing Sophia, because you can see here, Sharing Sophia, it's deployed between your application and your databases. So all of your queries first reach Sharing Sophia proxy. Sharing Sophia can automatically do the data masking or data encryption or decryption. And so it sends the encrypted data into your databases, right? So you don't worry about that your data, it's all plain text in the databases, because Sharing Sophia can help you do all of the encryption work and decryption work. Yeah, so that's because you know that Sharing Sophia, another product is Sharing Sophia proxy. You know that at the name hint, it's the database proxy. Database proxy can help you do all of the features I mentioned earlier, right? Yeah, so that's all about the Sharing Sophia JDBC and Sharing Sophia proxy and the feature they can provide you. Actually, if you use Sharing JDBC, because it just implement the native JDBC, so no matter your databases, it's a PostgreSQL, MySQL, or SQL or Oracle, it's all works here, right? The next part about if you use the Sharing Sophia JDBC, then your deployment architecture will become the right column, right? At the beginning, your application needs to manage your database connection and data sources by itself. But now, Sharing Sophia proxy can help you manage all of the database instance, help you manage the connections, do the data sharding, to do the data masking or data encryption, all of the good stuff, right? And your application just focus on itself to use this distributed database system. Yeah. So, and another part that, how about if my application lives on the Kubernetes, right? If so, you can just use our Sharding Sophia on Cloud project to use the Helm charts, one command to deploy Sharding Sophia cluster in your Kubernetes cluster, and then let your application living in the Kubernetes to connect in the Sharding Sophia proxy. And Sharding Sophia proxy can help you manage all of the databases and do data sharding. And no matter your databases are on the cloud, are on the premise, or in the Kubernetes cluster or the RDS, just like the Sharding Sophia can connect to your databases, you can solve all of the issue, right? So that thanks to the computing and storage splitting architecture, that means your databases or storage nodes can located anywhere. Yeah. So next part, I will use the Sharding Sophia on Cloud project to do the demo show. And I will use the Helm to deploy the Sharding Sophia cluster and use the PostgreSQL chart to deploy the PostgreSQL on the Kubernetes. If you already have your RDS, then you can ignore this part and just use Sharding Sophia cluster operator chart to deploy Sharding Sophia in the Kubernetes. And let the Sharding Sophia connect to your RDS, then it can help you manage the connection and do the data sharding. So so we need first to do the deploy work. The second one, we need to do the work about to create your databases and sharding table. It's not a single table or standard table in a PostgreSQL database. It's a sharding table. That means this sharding table, actually, it's made up of many shards or many subtables or many physical tables. All the subtables located in different PostgreSQL instance. But for your application just visit Sharding Sophia proxy and it thinks that there's only one logic table named T user. But actually this T user consists of 4 subtables into 2 PostgreSQL instance. But here, each PostgreSQL cluster, it has the primary one and a replica one, right? So Sharding Sophia will send the queries to the primary one or replica one in this cluster. Also, if it found that the data or rows records existing the cluster 2, the group 2, it will send the query to your PostgreSQL cluster 2 to finish the routing work and the SQL parsing work, right? But here, if we want to define a sharding table, we need to use this distributed SQL. It's a Sharding Sophia SQL dialect, and to similar with your MySQL dialect or PostgreSQL, it's the Sharding Sophia dialect. It's a distributed SQL. You can see here, maybe before you can just use this create a table to create a single table, but here you need to use a sharding table, similar SQL language to create a sharding table. And this sharding table, you can see here, the sharding column, it's an order ID, and it used the harsh mod strategy to split one single table into 4 right? 4 subtables, 4 shards, right? So if we finish this demo and your application just with one of the sharding Sophia proxy, and sharding Sophia will do all of the internal workflow, and it will use the sharding algorithm or strategy to help you locate the exit table where your expected record locate, right? And if it found that it's a select query, it will also to leverage replica to send the query to one of the replica. Therefore, you will find the QPS of your district of this new database system will become higher because it will automatically do the rewrite splitting such features. Yeah. So the demo show will include the following steps, and I do it by myself, but actually I have no time to introduce more. If you have this slides, you can follow my guide and to do it by yourself. First one, deploy the cluster by use the sharding Sophia proxy charts, and then use the distributed C code to create the sharding DB sharding table to make sharding Sophia be aware sharding Sophia aware of your databases, and then do some of the queries to test it's okay or not. All right, so that's all about my talk. And if you really have some questions, and we can talk later, or you can just give me the message on my LinkedIn or GitHub or Twitter, right? So see you later on. Bye.